Alright, so in this section we're going to talk about motion blur. Now you're not going to be able to see motion blur in your render view, so we'll be doing this section in the picture viewer. So the idea with motion blur is to recreate the effect of a shutter being open for a duration of time while an object is moving, and therefore blurring the edges based off of its movement. There are two types of motion blur. There's transformation motion blur, which Redshift will understand through an animated parameter. So it's just the object being transformed through space. And then there's deformation motion blur, which is specific to deformations of the actual object. So for example, if our sphere was static and suddenly a point poked out of the side of our sphere based off of a deformation, we would want to see motion blur on that, but that takes a different type of motion blur, which is the deformation motion blur. In this case, we're only working with transform motion blur, so we don't need that on. So to start with, let's talk about how we sample time with motion blur. I'm actually going to move my timeline a little farther into the animation, and we're going to notice something kind of weird goes on. So it looks like at the beginning we have less motion blur, and in the middle we have more motion blur. Now these are just linear keyframes moving left to right for my object, so we shouldn't actually see any variation in our motion blur. And I'm wondering why that is. Well, it actually has to do with the first thing we're going to talk about, which is shutter position. By default, we come set with center on frame. Center on frame is essentially going to say, okay, cool. When looking at our time, let's say we're going to sample directly on our frame, and then we're going to sample evenly this way and this way based on our shutter start and our shutter end. Now, if our shutter start was 0 and our shutter end was 1, we'd actually start sampling from this point in space halfway into the previous frame, and then we'd sample forward halfway into the next frame. And that is what we would be sampling. However, because we have it set to 0.25 and 0.75, we're actually only going to sample a quarter of the way in the negative time direction and a quarter of the way into the positive time direction. And that's because with our shutter start and shutter end set to 0.25 and 0.75, the middle space between that is at 0.5. So if we've got 0.5, we've got 0, and we've got 1, 0.25 will be halfway back, and 0.75 will be halfway forward. Now, here's a tricky situation. Let's say I'm set at center on frame, and I'm on frame 1, and I have no animation before it. I go to sample this direction, and Redshift is going to think that for the first half of the duration of the motion blur, the object is static. And then the second half, it's animated. So in this case, center on frame actually wouldn't work. What we'd want to do, since there's no animation beforehand, we want Redshift to think that we want to start sampling motion blur on our frame, and then we want to sample all the way forward to the next frame. The way we do that, we're going to want to use start on frame. So let's take a look at what that looks like. And now you'll see that we're properly sampling our motion blur, whereas when we had center on frame, we had very little motion blur. Now end on frame does the same as start on frame, but in the opposite direction. Frame duration is actually a pretty interesting one. So right now, frame duration is set to 1, which means the scale of the motion blur is only going to consider 1 frame in temporal space. But let's say we set this up to 5. Now, we're going to have motion blur as though we're sampling over 5 frames. And you can see that our result is rather insane. When I compare the physically plausible motion blur with our ludicrous frame duration motion blur, However, maybe you're just going for a still frame effect and you actually want your motion blur to look like this. Frame duration is what's going to get you there. Now let's talk about transformation steps. For that, I'm going to use a different animation. So you can see in this case, we have this animation that arcs upward in a curve. And so I would expect to see my rendered motion blur also arc upward in a curve. However, when I press render, you're going to see that we just have this very linear motion blur, which seems like it's a problem. And that is where transformation steps comes into play. So transformation steps is referencing basically how many samples along the animation we're going to reference for the motion blur. So if I stick transformation steps up to 3, we'll now have a little bit of an arc, at least. You'll see we have just a very slight arc going on here. So basically, the higher the transformation steps, the more samples you'll get along that animation curve. Now lastly, we've got shutter efficiency, which is actually a pretty cool one because it helps us control the look of the trails of our motion blur. With shutter efficiency set to 1, it's going to be as though the aperture perfectly opened and perfectly closed, which is rarely ever the case, and we get this kind of unnatural effect to our motion blur. You can see it's equally strong through the entire temporal duration. However, if I start to lower shutter efficiency, you'll see we start to get the effect of the shutter being fully open at the middle of the frame, and then our trails fade off in intensity in the positive and negative time directions. So it gives us a bit more of a physically correct look to our motion blur. And if I drop my shutter efficiency way down to 0.1, we'll get something that looks a lot closer to something like we've seen before in traditional photography. All right, well, thanks for checking out the section on motion blur. If you'd like to know more about rendering your motion blur and getting rid of noise, go ahead and take a look at the sampling section, and we'll see you in the next one.